Hey guys, welcome to another video. This video is going to be the first of many. This is going to be a series for revision for calculus during the winter break. So if you're planning to study in the winter break, this will be very beneficial for you, or if you're studying at any time whatsoever. As you can see over here, this document is made by a guy that named himself CR Calculus apparently. I will putting the link in the description for in the video in case you want to download the digital version of this PDF. It's for free on his account, and there's a lot more resources you can find over there, but they actually cost money if you're willing to pay money and you want to support this creator. But this one is for free, so if you go to the link in the description, you can download it and you can add it to your Google Drive. So let's begin. Use the graph f of x below for all questions. In number 1, they told me to evaluate limit as x tends to 1 for f of x. Now, if you're looking at x equals to 1, you can see that the function is approaching 3 on both sides. So it's basically equal to 3. Now, in number 2, they asked me to evaluate limit as x tends to 4 for x squared minus 16 over x minus 4. This is going to be limit x tends to 4, x minus 4, x plus 4 over x minus 4. X minus 4 is going to be simplified, and then x plus 4 is going to be remaining, which is going to be 4 plus 4, which is 8. In this case over here, by the way, you can literally say that x is equal to 4 in this case is a removable discontinuity because you crossed it out with the numerator. In number 3, they said, for what value of x does g of x equals the following have a vertical asymptote? In this case over here, we need to use our calculators to find the roots of the denominator. So if you use the calculator, the roots of the denominator is going to be x1 is equal to 3 and x2 is equal to 2. So before you say that these two values are vertical asymptotes, rewrite the function. Because if you rewrote it, you're going to notice something over here, which is that x minus 3 can be cancelled out. So in fact, x1 is equal to 3 is going to be a removable discontinuity. And x is equal to 2 is going to be my only vertical asymptote over here. In number 4, they wanted me to find the value of k, which makes the piecewise function continuous. Now, you have to remember that in order for a function to be continuous, you must have the following equality, which is limit as x tends to 2 minus for h of x should be equal to the limit as x tends to 2 plus h of x should be equal to h of 2. That being said, you can literally place kx squared minus 6 equals 4x plus 10. Now, setting x is equal to 2, you're going to get 4k minus 6 equals 8 plus 10. And then you're going to get 4k is equal to 18 plus 6, which is going to be 24, divided by 4, divided by 4, and k is going to be equal to 6. Now for number 5, they asked me what x does f of x have a removable discontinuity. Now if you're looking at the graph over here, you can notice that when x is equal to 1, there is a discontinuity, but it's being filled by this black hole over here. So this is an indicator that x is equal to 1 is a removable discontinuity, because they're saying that we have a discontinuity over here, but we have a compensation. We have a substitute. Meanwhile, over here, we don't have a substitute for this discontinuity. Over here, we don't have a substitute for this discontinuity over here. So there's a jump over here, but however, over here, I can literally see the function being continuous from this side and continuous from this side. And on the discontinuity itself, it's getting filled with the black spot down. So at x is equal to 1, we have a removable discontinuity. Now moving on to number 6. In number 6, they wanted me to find limit as x tends to 2 f of x plus 5. So the beautiful thing about limits is that it can be distributed. So you can distribute the limit over here and it will be 2 limit x tends to 2 f of x plus 5. I wrote plus 5 immediately because limit as x tends to 2 for 5 is literally 5. So now limit as x tends to 2 for f of x, as you can see on the graph, it is approaching from both sides on x is equal to 2. The value of it is basically 2. So it is going to be 2 multiplied by 2 plus 5, which is going to be 9. Now in number 7, they asked me what is the horizontal asymptote for the function m of x, the following. Usually when you want to find the horizontal asymptote, you're finding the end behavior of a function. So you have to find limit as x is going to infinity for m of x, which is going to be equal to limit as x is going to infinity. Let me change color over here. So x squared plus ln x minus cosine x over e to the power of 2x plus x minus 1. Now, in this case over here, when you're dealing in the neighborhood of infinity, and this only works for when you're dealing with the neighborhood of infinity, you have to take into consideration that whenever you're in infinity, everything that is smaller than the bigger number gets eliminated. Like for example over here, if you're looking at ln, and if you're looking at cosine x, their values come nowhere near to the values of x to the power of 2. So you can literally eliminate ln x and cosine x from the numerator and leave out x to the power of 2. Similarly, in the denominator, e to the power of 2x is on a higher level, if you may, of growth compared to x and compared to -1. So it's going to be e to the power of 2x down. Now, this is going to be a note of a discussion over here because x to the power of 2 and e to the power of 2x, they formed a fraction over here. And we know that if a fraction is small, then when it goes to infinity, it's going to go to 0. But if, like what I'm saying is basically, if x to the power of 2, I'm going to write it on the top. If x to the power of 2 is bigger than e to the power of 2x, then the fraction, which is x to the power of 2 over e to the power of 2x, is going to go to infinity, because the fraction is going to be bigger than 1. However, if x to the power of 2 is smaller than e to the power of 2x, that means that x to the power of 2 over e to the power of 2x is going to go to 0. So which one is it? We know that a quadratic function is on a slower growth than an exponential function, which means that x to the power of 2 is always smaller than e to the power of x. However, e to the power of x is doubled in this case because we have e to the power of x, e to the power of 2x, which means that x to the power of 2 is going to be definitely smaller than e to the power of 2x. So that means that this function is going to end up going to 0 because e to the power of 2x is bigger than x to the power of 2. So you can write so over here. So y is equal to 0 is a horizontal asymptote. Now, in number 8, they asked me if n of x is a continuous function, how many roots are guaranteed by the intermediate value theorem on 0 to 12? So over here on 0 to 12. Now, as you can see over here, n of x was positive over here, and then it was negative. And they told me that this is a continuous function. So over here, it touched 0. And then over here, it touched 0 again. because it's going from a negative number and it became a positive number. So obviously at some point in between, it touched 0. And over here, it touched 0 again. And over here, it touched 0 again, and it touched 0 again, because the signs keep changing. So whenever you see a positive number turning into a negative number and vice versa, you know for sure that the function crossed the 0 mark. So how many times did it cross it over here? 1, 2, 3, 4, 5. So how many roots? 5 roots. Guaranteed by the intermediate value theorem. If you want to explain more, you can say that there are 5 roots present because the sign changed a total of 5 times. You can say like from x is equal to 0 to x is equal to 1, x is equal to 2 to x is equal to 4, and so on and so forth. Now in number 9, they told me let p and q be functions defined by p of x cosine x minus 2 plus 6, q of x minus 2 to the power of 2 plus 7. If r is a function that satisfies p of x smaller than r of x smaller than q of x for all x, what is the limit for limit as x tends to r of x? This is a blueprint for squeeze theorem. So writing this inequality over here in front of you, it will make a lot of things easier. So it will be cosine x minus 2 plus 6 smaller or equal than r of x smaller or equal than x minus 2 to the power of 2 plus 7. Now inserting limit as x tends to 2 on every single side. What we're going to have is going to be limit as x tends to 2 cosine x minus 2 plus 6 limit as x tends to 2 r of x limit as x tends to 2 x minus 2 to the power of 2 plus 7. Now evaluating it, if you're putting 2 instead of the x over here, 2 minus 2 is going to be 0. So cosine 0 plus 6, cosine 0 is 1. So 1 plus 6 is going to be 7. So we're going to have 7 from one side. Limit as x tends to 2 r of x. And on this side, if you plug in 2 instead of x over here, you're also going to get 7. So the limit of r of x as x tends to 2 is between 7 and 7. Therefore, the limit for x tends to 2 r of x is in fact equal to 7. The final question for this video, they said to evaluate the limit of x tends to 1 for f of x plus f of x. As we said before, that limit is distributed. So you can say that this is going to be equal to limit as x tends to 1 for f of x plus limit as x tends to 1 f of x. Now in this case, we have a composite function over here. And in a composite function, the rule says the following, that the limit for x tends to 1 for f of x is going to be equal to the f of limit as x tends to 1 f of x plus limit as x tends to 1 f of x. Limit as x tends to 1 f of x, it is going to be 3 because it is approaching 3 on both sides over here. X is equal to 1. So we're going to find f of 3. And f of 3 is basically the black hole over here, which is 0. So f of 3 plus, as we said, limit as x tends to 1 for f of x is 3. So 0 plus 3 is equal to 3. This is it for this video. Be sure to tune in because I will be posting the same exact criteria, but for Unit 2 and Unit 3 and Unit 4 and Unit 5. Thank you so much.